Welcome to qnawire.
Chapter 16, Problem 118. The volume of an adult stomach ranges from about 50 milliliters when empty to 1 liter when full. The stomach volume is 400 milliliters and it contains to have a pH of 2. How many moles of H plus does the stomach contain? And then assuming that all the H plus comes from HCl, how many grams of sodium hydrogen carbonate will totally neutralize the stomach acidity? So the first thing to note here is that it says if the stomach volume is 40 milliliters and contains to have a pH of 2, we are going to be looking at a volume of 400 milliliters for the pH at 2. So the first thing we need to do is find the concentration of H plus to then find the moles of H plus. So to do that, we're going to do our H plus concentration is equal to 10 to the negative pH. And so we're going to do 10 to the negative 2. And when we plug that into our calculator, we get 0.01 molar solution. So now since we have the molarity, now we need to find our moles. So molarity is equal to moles over liters. One important thing is whenever you are using this equation, your volume has to be in liters. And so what you're going to do is you're going to do 400 milliliters and convert that to liters. So there's 1,000 milliliters in 1 liter, and so therefore you get 0.4 liters. So going back to the equation of molarity is equal to moles per liter. To find your moles, you just multiply over your liters. So moles times liters will give you your moles. So you're going to do 0.01 times 0.4. And so when you plug that into a calculator, you get 0.004. So that is how many moles of H plus is in the stomach. So that's for the first part of the question. The next part of the question is asking us how much of sodium hydrogen carbonate will be used to totally neutralize the stomach acid. And so to be able to do that, we had to write out our equation if we add sodium hydrogen carbonate to HCl. So we're going to write HCl plus NaHCO3 goes to H2CO3 plus NaCl. And so for when we're looking at this, we need to make sure everything is balanced out, and it looks like that. So we have a 1-to-1 ratio of moles of HCl to NaHCO3. So if we have 0.004 moles of HCl, then whenever we do stoichiometry, so 1 mole of HCl to 1 mole of NaHCO3, we would still have 0.004 moles of NaHCO3. So the next part of the question is asking how many grams. So to find your grams for moles, you multiply by the molecular weight. And so we know we have 0.004 moles. And then we multiply the molecular weight. To find the molecular weight of NaHCO3, you're just going to add up your molecular weight of Na plus your molecular weight of H plus your molecular weight of carbon plus 3 times your molecular weight of oxygen. And when you do that, you get the molecular weight of 84.0 grams per mole. So we're going to multiply that out. And when we plug it into our calculator, we get 0.34 grams. And that is our final answer.